Hey engineers, and welcome to Fluid Power Introduction. Today we're going to be talking about fluids, and a fluid can be a gas or it can be a liquid. Anything that can occupy its container is known as a fluid. There are differences between liquids and gases, which I'm sure maybe you know, maybe you don't know. We'll talk about how hydraulics work, how pneumatics work, why they work. The pros and cons of a hydraulic system versus a pneumatic system, how to calculate what a hydraulic system can do. We'll put it in terms of work, energy, and power, and then some schematic symbols. So let's get started. I first wanted to come over here and I don't know if when you think of hydraulics, maybe, I don't know what you think of, but I just did hydraulics GIF image search, and maybe you've seen hydraulics in a car. That's what makes a car do all these crazy things. It's definitely from hydraulics. There's a really great animation here of truly what's going on inside of a hydraulic cylinder. You're going to push down on this plunger, which is going to make this one go out. Watch. So you push this down, you push fluid into here. This fluid that you moved is equal to the fluid you moved over there. So these volumes are the same. Pneumatics. We'll come back to that. This is really great. It basically shows everything you need to know. Here's another great GIF here. There you go. Hydraulics in a nutshell. The ability, it's kind of almost a simple machine in a way, where you're taking a small, see how this is very small, and you're moving it a lot of distance, but then you can take something big and you move it with a small distance. Kind of like that trade-off with simple machines. Like if you want to exert a little bit of power, you're going to have to do a little bit of force. Then you're going to have to do a lot of distance. The same is exactly true inside of hydraulics and pneumatics too. I did an Google image search, GIF search for pneumatics. Here's a pneumatic cylinder. You push air into this, which pushes this piston. And that piston is connected to a rod. And that rod we can make into linear motion. So we use pneumatics all over the place, hydraulics all over the place, to make linear motion. Maybe you need a lot of power, or maybe you need a little bit of power. It all depends. And you saw in the previous chapter where they were animating a Tyrannosaurus Rex. They were doing that with pneumatics and hydraulics and electric actuators. So they were using electricity to drive a motor, but they were also supplementing that with a pneumatic system that was making it what they called neutrally buoyant, so that this electric actuator, which was much smoother and would work less maintenance for a longer period of time and make it easier for them. This isn't going to do anything. Let's get started. Some definitions. Fluid power. The use of a fluid, so that could be a gas or it could be a liquid, to transmit power from one location to another. Hydraulics. Hydraulics is specifically using liquid, hydraulic fluid. You're using a liquid, and a liquid is incompressible. So when you push on a liquid, it is not going to stretch or get smaller. It's going to keep the same volume. Pneumatics, that's when you use gas. So using an air, like maybe you've heard of a pneumatic wrench, like a woo woo sort of thing. That's using air to turn. And air you can compress. So there are pros and cons to both of them. Why would we use it in the first place? So you can use it as a simple machine. So you can increase your power, or your force, or you can increase your distance, depending upon if you have a mechanical advantage bigger than or less than one. It's very easy and accurate control. Hydraulics are much more accurate than pneumatics, but pneumatics are much faster. One power source, you can control many operations, so you just have to hook up to one compressor or one pump, and you can control all sorts of other things. There's a high power to weight ratio, so not a lot of weight to move things. Low speed torque, meaning, I'll explain to you what that means. Like you can use hydraulics to turn in a circle, which is interesting. I've always wondered, like, how do they hook on a bobcat? How do they hook a brush that keeps going in a circle? Or how do you hook a drill up to it and make a drill keep going? That didn't make sense to me, but now it totally does now. But how do you get things that move really slow to have lots of power, lots of force? Constant force and torque. And it can be safe in hazardous environments. Basic components. Every fluid power has got these things. You got a place you got a tank. At some place there's a tank to store fluid that's not being used. Sometimes it leaks, but you need to store that air or liquid somewhere. You need to have a pipe, some way to move the fluid throughout the system. You need to have something that pushes that fluid through the system. It can be a compressor, it could be a gear pump. I'll explain to you what a gear pump is in a second. And you need to have something to turn it on and turn it off. A valve that controls, think of like the valve on your water faucet, the valve on the outside of your house to turn water on and off. You need some way to turn that air, turn that liquid, let it flow or not let it flow. And then you need some actuator, something for it to physically do, a load. So you're turning that, you could either be turning something or you could be pushing an actuator forward and backward like you saw in those GIFs at the beginning. Some examples in construction. These are all hydraulic actuators. This thing right here, hydraulic actuator. Agriculture. If you ever have used any agricultural equipment, they've got those hoses that you plug in the back of the tractor. You're using the tractor as the pump, and then the actuators are on the implement that you're using. This is a simulator. You saw these with our guy with the pool cue. He was using pneumatics to control this. No, he was using cables to control this. So this wasn't fluid applied. This was like cable applied. I forget what they called that. It was something. Robotics, helping people, manufacturing, and then in the entertainment industry, anytime you've got motion, if you want to move something, it's generally going to be used with hydraulics, pneumatics, or you could use electric actuators too nowadays. The physics of all of this, energy, you're moving energy from the pump to our motion. And remember that work is your force times your distance. So if you're taking 1,000 pounds and you're moving it 2 feet, the amount of work you're doing is 2,000 foot-pounds. And here's the secret with all of these, and the same thing is true with our simple machines, is that the work you put in is equal to the work you get out. It's not exactly equal because we get into efficiency, but if you put in 2,000 foot-pounds of work, you're going to get out almost 2,000 foot-pounds of work, depending upon your efficiency. Power, it's that work divided by time. So in this case, if it took us 2 seconds, so you're going to take 2,000 foot-pounds divided by 2 seconds, that's 1,000 foot-pounds per second. 1,000 foot-pounds per second. Now you can change this directly into horsepower. There's a conversion between foot-pounds per second. Like how many foot-pounds per second is 1 horsepower? How many foot-pounds per second is 1 horsepower?
According to Kyle's converter, 550 feet lbf.
550. So if you have 550 foot-pounds per second, that's equal to 1 horsepower. Now we can convert that into stuff that we're doing with hydraulics too. When we start talking hydraulics and pneumatics, it's the flow, how many gallons per minute, how fast is it flowing, multiplied by the pressure, and then you divide by some constant, 1714, and that gives you how many horsepower. So they have one over here, an example, that here's a pump that's pumping 10 gallons every minute, and it's under this much PSI, 1,500 PSI. You multiply these two things, so that's 15,000, and then you're going to divide by 1714. So 15,000 divided by 1714 is 8.75. So this is an 8.75 horsepower system. And so you can do that amount of work, 8.75 horsepower. That's the amount of work that this is capable of, assuming it's 100% efficient. So, this 10,000, remember we talked about if we want to do 10,000 pounds in 3 seconds, so that's something on the order of like 3,000 horsepower. No, so that's 3,000 foot-pounds per second. And remember that it was like 550 horsepower. So just doing a quick calculation here, if you take 3,000 divided by 550. So that's about 5 horsepower. So to lift this, it only takes 5 horsepower, so this is totally going to do that. Heat. So when you compress something, it's going to create heat. That energy can either be created or destroyed. When you compress, you're going to give off heat. So a lot of times, here's like an example of a radiator. So when you create heat, you somehow give heat back to the universe. Torque, if you remember back, torque is force times distance. So 10 pounds times 1 foot. This has 10 times 1, which is 10 foot-pounds of torque. Inside of a motor, so this fluid can spin like a turbine. So you can use a pump to inside here spin a turbine. And this is how bobcats can rotate a brush, or they can rotate a drill, or anything that they can continue to rotate. They use their hydraulic motors to do that. Flow is how much fluid is working. So here's your first example of what we call it's a schematic for hydraulics. So right here, here's a pump, and you can see it's denoted by this circle thing, and the arrow represents how the direction that the fluid is flowing. So here is the fluid flowing. This thing at the bottom is the reservoir. So here is where it's pulling the fluid from. So it's sucking up fluid from here, pushing it there. This is our valve. And this is kind of tricky to understand. It took me a long time to understand these, and I'll explain this. But these are springs, so you can push this valve down, or you can push this valve up, and it will allow fluid into port A, which retracts the hydraulic cylinder, or you can push fluid into port B, which is going to extend that actuator. So there's our actuator. So these are kind of schematic symbols. This is a filter. This little diamond thing here, so like the fluid as it passes through, if it picks up any dirt or debris or grime, you pass it through a filter before it goes back to the reservoir, so it doesn't get caught in the motor or any other parts. So here, check this out. So you see this actuator right here? If I push that actuator up, if this goes up, watch what happens. Do you see how the red goes down into port B, and it's going to push the actuator out. And then the blue is going to go back here, and it's going to go through the filter back to the reservoir. So if you've ever used like a log splitter or any sort of hydraulic implement, there's that lever that you're pushing. This is inside the internals of that lever. This is the valve. So when you push this up, it's going to connect the red line down here to port B. And it's going to connect the output, port A, go back to the reservoir. Now I can push it down. Watch what happens if I push this down. So now I can take the pump, which is pushing the fluid, it goes through that valve into port A, and it retracts that cylinder. So now you're pushing the cylinder, the actuator, backwards, and then that fluid that was over here gets pushed into the reservoir. So that's how like a valve works. So it can be the neutral position, where right now the hydraulic pump, it's pushing fluid around this corner back in. So it's just cycling fluid through into the reservoir. So then when you have it in this position, you extend it. And then when you take it to the other position, you are retracting the cylinder. Flow rates. We measure it typically in the United States. Everywhere else, it's like liters per second or liters per minute. But poor United States, we use gallons. So gallons per minute. So how quickly our pumps are pushing, we rate it in gallons per minute. So I popped over here to Google and I typed in gear pump GIF because for a long time I didn't understand how hydraulic systems work. And here's just an example. If you have an electric motor, this electric motor, let's get a good one here. Come on. There we go. Check this. So an electric or gasoline engine is turning this center, and so the fluid comes in and it gets pushed around this way. So here's how, this is a way like a gear pump would work. Hopefully here's another better way to example. See how the red, it comes in from the right, and these gears are forcing that fluid forward. So maybe you're like, if you have a lawnmower, if it's hydrostatic, it's using these gear pump ideas to push that fluid. So the fluid gets pushed by the gears. how can a hydraulic, maybe you've heard your engine bog down, like, oh, if I'm lifting something really heavy, because there's a direct link to the motor, and that's why things bog down when they do. Maybe this is a cool GIF. Oh yeah, that's pretty sweet. Shows exactly how the fluid is getting pushed from one side to the other. Kind of a nicer. So here's where I'm going to stop today. I've got a few more slides to get through, but I thought, man, we're already at like 15 minutes. Let's cut it off for today, and we'll continue tomorrow. So we got an introduction to fluid power. It could be hydraulics or pneumatics. We talked about the different things that it has to have. Kind of a little introduction to the schematics and how valves work, and then how this gear pump, how a physical gasoline engine or an electric motor can push fluid through pipes.